In our first lesson of Unit 4, we are going to revisit square roots and how to find the square root of something. Remember that when it comes to solving equations always have an equal sign. We use inverse operations. The opposite of positive is negative, and negative is positive. The opposite of multiplication is division, and division is multiplication. And the opposite of squaring is square rooting. However, we are now going to add something to what we've already learned. Whenever taking a square root, two answers are always possible, because it is impossible to know if the original value was positive or negative. And I'm going to show you what I mean by that in example 1. So in example 1, I want to isolate x squared. I know that the opposite of x squared is square rooting. But whatever I do to one side, I do to the other. So I take the square root of the left and the right side. In expanded form, this would look like x times x equals 4 times 4. Now I know that this is going to be x, because there is a perfect group of 2. And remember, our radicand when not written is always 2, so we have a perfect group of 2. Now 16. I know that 4 times 4 equals 16. But I also know that negative 4 times negative 4 equals 16, because a negative times a negative is a positive, and a positive times a positive is a positive. So it's impossible for me to know if the original number was 4 or negative 4. So I'm going to bring both of these numbers out. This is the long way of writing it. In shorthand, we typically just put a positive over a negative in front of the 4, and this means that we have a positive 4 and a negative 4 as our answer. So these two things are the same, but this is the shorthand way of writing that. We're now going to add a few more steps to our problem. So now we have a plus, we have a multiplication, and we have a square. So I know that I'm going to have to use a few inverse operations. My first step is to subtract 4 and bring down 2x squared. 28 minus 4 is 24. I divide by 2 because the opposite of multiplication is division. This gives me x squared equals 12. Now once again, the opposite of squaring is square rooting, so I'm going to take the square root of both sides. I know that this simplifies into x, and this can be rewritten as, if we broke it down, 3 and 4 and 2 and 2. So because we have a perfect group of 2, I'm going to pull one of those out, and we are left with x equals 2 root 3. But these 2's that we pulled out, or the 2 that we pulled out, these could have been negatives. It could have been negative times a negative, which would have still given us a positive 4. So because we can't tell if the original numbers were positive or negative, we're going to account for that by giving a positive and negative answer. And in the shorthand way of writing that, it's plus or minus 2 square root 3. In our last example, we've now expanded the squaring to be an expression. So we're squaring an x minus 1, which is an expression. This is going to be solved in the exact same way. Our first step, once again, is to always get rid of stuff that's like adding or subtracting or multiplying or dividing first, and then do square rooting. So that's something that's super important. You always want to do these two things first, these two second, and this one third if possible. There are situations where that might not be the case, but most of the time it is. So we subtract 4, giving us x minus 1. Quantity squared equals 28. I now need to get rid of the square. I can't touch the x inside of the parentheses until the parentheses are gone. The parentheses are not gone until I get rid of this square. So just like before, I'm going to take the square root of both sides. If we expanded this, it would be x minus 1, x minus 1. This is a perfect group of 2, so I'm going to eliminate 1 and bring 1 out, leaving me with x minus 1 on the left-hand side. This one died, this one escaped, leaving us with nothing inside. This 28 could be broken down into 2 root 7. But again, we don't know if this is a positive or a negative 2, so we're going to put plus and minus on the outside. And then in our last step, we have one more step. We need to add 1. The 1's eliminate, and this gives us x equals positive negative 2 root 7 plus 1.